Good morning, everyone. How's everyone feeling? A little bit dusty from the evenings? I'd like to all welcome you today here. My name's Lucas. For those of you who don't know me, I'm one of the program committee members for AusCert, as well as one of the organisers of B-Sides Melbourne, for those that were down there last weekend. Hello again. Also, I'll just kindly remind you around the AusCert app. So if you do want to download the AusCert app and you have questions for any of the speakers today, you can submit your questions through the app. Otherwise, I'll just get my steps up and run around with the microphone. Right. I'd like to respectfully acknowledge the people of the Yugambeh language region, the traditional owners of the land on which we all meet today, and pay my respect to the elders, past, present, and those emerging. I would like to particularly acknowledge my wife and her family, who are descendants of the land on which we meet here today, and thank them for all they've taught me about their culture, and extend my respects to any First Nations people here joining us today. Right, so I'd like to introduce Chris Haller. Hopefully I'm pronouncing it right. So Chris leads offensive security at Omada Technologies, covering red and purple teaming, AI security, and hybrid identity. Former US Navy with a decade of experience, including Navy Cyber Defense Operations Command. He's co-authored The Hack is Back in 2024, has discovered numerous CVEs on attack and defense, and is the coach for the US Cyber Team competition that was just out here last week, or this week. He built ProfileHound himself, open source tooling that extends BloodHound into cloud-centric red team territory. So can we have a warm round of applause for Chris Haller, who flew all the way here from Boston. Thank you.
Appreciate it. Excellent. All right, so thank you, everyone. We got a short time window here, and I got a lot of things to cover. So we're going to move fast, and please let me know if you have questions. I'm going to try and cover a lot of technical things really fast. Don't worry, we got pictures, we got colors, so it's all good. All right, so getting started, what we're going to do is going to cover kind of some expectations of what I'm going to be talking about today. A little bit about myself, so thank you, Lucas, for the introduction. And then we're going to talk about kind of what red teaming is just in general, super high level, why it's different from pen testing. Then we'll talk about legacy, SSO, and modern cloud-based identity providers, hunting for SaaS applications, targeting versus looting. If we have time, a quick demo, and then also some defensive perspectives. So getting first into kind of what you can expect to see in this next 35 minutes, we're going to be talking about identity. And identity is a very big buzzword, right? You hear it everywhere, especially with things like AI agent identity. Don't worry, I'm not talking about AI today, all right? You'll get that plenty of other places. Hopefully this is a little refreshing on that side. But we're focusing specifically on post-compromise, post-escalation, and actions on objectives. So what this means is not just, hey, you get domain admin. It means, hey, we actually got something that compromises the business and the way that a business or an organization actually conducts what they do. So just owning domain admin really doesn't mean anything unless you can actually prove stopping business operations. So BloodHound is used to visualize this information. This is a tool that we'll get into a little bit more about. What my tool does actually extends on what BloodHound gives you and gives you additional information to help find and sniff out those specific cloud-based identity and credentials. So a lot of technical items. Again, please don't be afraid to ask questions or get ready to ask questions, but we're going to be moving fast. So a little about myself. I did 11 years with the US Navy, 8 active, 3 reserves. Way too many certifications, but the one I'm the most proud of is my GSE as GX Security Expert number 329. Very involved with SANS, very involved with CTFs. I'm a coach for the US Cyber Team, and we were competing earlier this week, and we ended up coming in second overall, first in Jeopardy, and very, very proud of what all the players on the Cyber Team have done, and so excited to see what we're going to continue doing in the future as well. Yep, there we go. We got some players back there, so please, if you see them, give them a firm handshake. I love speaking about technical things. I love talking and describing about technical things. I work for a reseller doing consulting work in Portsmouth, New Hampshire, and that is Omada Technologies. Very thankful to be there. Love working and helping people. And my passion is really about finding a practical approach over theory, because we can do anything in theory, right? But when you actually prove that this is a problem, then people have to do something about it. So it is so personally and professionally rewarding to be able to help find and fix bad things before the bad people do. And that's why I love doing what I do and how I do it. So we're going to get into what red teaming is very, very quickly. This is specifically objective driven. Now what that means is that it's not just, hey, we're trying to find as many vulnerabilities as possible or prove as many vulnerabilities as possible. That's pen testing. Red teaming is specifically, you need to try and get access to our payroll SaaS so that we can prove that our payroll is secure. Or, hey, we have some very specific HMIs that are used to run some specific ICS need that we do, whether it's producing materials or generating power. So your red team objective is, can you get to a point where you could possibly compromise those systems that generate the power or produce materials or really conduct what the core mission of the organization is. So what are the things that actually cause the business money or prevent them from doing their primary mission? And on top of all this, the only reason we do something involving red teaming is because it ends up making the blue team better. It's not because we're just trying to show how cool hackers we are or what kind of amazing things we can do and all that. It's ultimately we all work together and we are all putting these things together so that we can help make the business better. Everything comes down to outcomes. Again, if you get domain admin, that means nothing unless you can actually prove that you compromised those business applications that are required for the business operations. So it really boils down to, did you actually do the thing, right? So big part of this is Active Directory. You may or may not be familiar with Active Directory, but it's been around for a very, very long time. Monolithic single sign-on, way back in, I think, early 2000s is when it first came out. Fantastic, right? But it is also a bear in the same time that it's hosted on site. We had traditional sysadmins that were, building and maintaining and doing all these systems to tie in business operations and business applications into Active Directory. And their primary focus is putting things together so the operations can run. Secondary focus for sysadmins is security, but their primary focus is always getting the operations running. So, and this is way back in the day, right? Where all the servers were actually hardware, you had to actually touch them, and we only paid licenses once instead of on a monthly basis. So, but what this meant was that when everything was connected to Active Directory, that compromise was completely catastrophic. So compromise of Active Directory itself, if you get domain admin, means that every single business line was compromised at the same time and directly, because they're all tied in together, so they require Active Directory in order to tell who is and who is not allowed to use those systems. So if you compromise that single source of truth, you control everything, because that's how the things were connected back in the day. So here's another kind of quick graph that hopefully helps visualize what that looks like too. So, and it's also really important too from the red teaming perspective that domain admin doesn't mean, or it's not the objective, right? It is a way to get to the objective, to get to that point where, we get this core intellectual property down here. Because if you can compromise Active Directory as the domain admin, you control the ways that people authenticate and who authenticates to the actual intellectual property, because it's all tied together. Now, nowadays, people are getting really sassy, right? So moving off of premise, going into the cloud, moving into different types of subscription-based services. I mean, most brand new businesses are just straight hybrid or cloud only, right? And it's fantastic because it's great for the users. They don't have to deal with a VPN. They don't have to deal with managing all these different credentials, all this crazy stuff. But all the identity models now move into cloud-based IDPs or the SaaS directly themselves. So what's really interesting is that now this graph changes. So instead of us compromising domain admin, and then we have Active Directory for all business lines or lines of business, all of these usually go through some kind of cloud IDP, and that results in MFA or conditional access policies or some kind of specific app rules or something that's actually in the way now through the cloud IDP. So that prevents going directly from domain admin on Active Directory into some kind of SaaS-based application hosted in the cloud. And that's not to say that you can't do that. You absolutely still can do that. It's just not as direct anymore. So another really interesting thing to pay attention to in today's environment is that specific individuals don't even necessarily need to use an IDP. They can just sign up for a SaaS application and then store their username and password combos directly in their browser. So at that point, it's not touching Active Directory at all. It's just hosted inside of their browser, saved in their password manager, something along those lines. And us as red teamers, how do we actually find out, okay, where does someone have these credentials saved for this SaaS? And how do we actually find this information? Good news is that those do get saved on a machine, and they get saved in a place that can be found and can be extracted from. But the problem is that if you have 3,000 machines on a network, where do you even start trying to figure out where those credentials exist for that one very specific SaaS application? How do we actually go through this data and figure out where these things are tied together, and how do we extract that in order to move forward and achieve the objective? So what we're doing is we are looking for those user profiles that are associated with that SaaS application or some kind of high-value user that we know is supposed to be using that application or some kind of cloud information that gets us to that objective. And then we are going to try and find where their profiles are stored and then how we can gather that information from their profiles. Because again, if we're looking through 3,000 machines and trying to figure out, okay, who logged in here in the past, who might log in the future, if they logged in once and never used it again, what kind of information do they have? So we need to be able to do this effectively and at scale. Some other really important things to understand is that when we find a user's primary machine, the one that they use as their daily driver to conduct business, that means we can find long-term refresh cookies so that we can do MFA bypass. Or even in some instances, we can just route our traffic directly through their machine. So then when we are accessing the SaaS application through their machine, it looks as if it's coming directly from them at that point. And then that gets through all the conditional access policy bypasses and these other things. But that is so hard to do unless you know exactly which machine is their primary machine. If you don't have that information, we're not going to get the credentials, we're not going to get the identity, and then we're not going to get that extra benefit for things like MFA bypass. So being able to find that machine is key. Now, BloodHound itself. This is an open source tool that is used to help visualize attack paths, built by Spectre Ops, and really helps see and visualize what this looks like so that, obviously Active Directory gets very complex. Complexity is the enemy of security. And being able to actually graph this out so you can see how all these different relationships feed into each other, give that information about how we can make informed decisions. So one good example of this is from the Game of Active Directory Lab. This is just normal BloodHound gathering information. What we can see and visualize really is that Samuel Tarley, he is just a user, normal level user, nothing special, has the ability to modify a GPO that is linked to the domain, and that specific part of the domain does have the users, which has the domain admins group as a member. So effectively, Samuel Tarley can take over the domain admins group through these different relationships and how they're graphed together. And this is really, really hard stuff to visualize and see unless you can actually visualize it and look at it in this kind of graph database. So just looking through lists of ACLs, just puts you to sleep, right? And how do you actually make something actionable out of that unless you have something like this that helps you really visualize what it looks like? Now, another really important part about BloodHound is that it has this edge between nodes called HasSession, and what that represents are live logins onto a machine. And good news is that if someone's logged into a machine actively, that's probably a pretty good indication that they have that as a machine that they use somewhat often. And if we can figure out, like, hey, which group has the high-value SaaS or cloud individuals, and then we can see, oh, they have a session on this specific machine, that is a really good indication that we need to look at that machine, see what kind of information's there, can we steal any additional information, and then really kind of focus on that machine to pivot further to achieving the objectives, right? But the problem is that the sessions are only good for 10 hours by default, and if a user is not actively logged into a machine when we collect this data, it shows nothing. So it's really hard to correlate whose machines are their primary machines or not unless they just happen to be logged in at the time where we're collecting this data. Now, the last thing about BloodHound directly is that version 8 came out with what's known as Open Graph, and that allows people to extend BloodHound natively. So what this means is that you can create a very specific schema of JSON input that can correlate to existing nodes that exist in the BloodHound database, and then actually drop them in, and then add new edges, new nodes, new information that extends the vanilla information that gets covered by BloodHound and SharpHound. And this is really important because in the past, in order to get the benefits of visually graphing out this information and some like very specific custom information, you would have to do a custom fork of BloodHound and then deal with all these extensions and modifications, and it was a real pain in the butt. But now that Open Graph is supported natively, all you have to do is just drag that new file in, and then it'll correlate to everything that already exists in there. So there's some really, really cool projects online that really go through graphing all of this new amazing data that can help visualize different attack paths. So that's why I built ProfileHound, because I do a lot of red teaming, and a part of that is trying to figure out the right profile that has the information. And I don't like doing it by hand, which I've done for a very long time, and it's a real time sink. So computers are very good at doing things repetitively, right? I don't want to have to do that over and over. So what we need to do is we need to find that user that has the access to the objective. Then we need to map out which system they have, how they have that system, and then really triaging on which ones that matter. And again, doing this by hand, just kind of crawling through machines, 3,000 or something machines, nobody can do that, right? Like, it's probably not healthy to do that either. So being able to actually build a tool that can do this for me and then even visualize this data so we can actually map it up together has been truly phenomenal. So what we're going to show here is a fictional scenario of our red team objective is to try and access the payroll SaaS application. And we find out through our intel as we're working through the environment that the group called Small Council has access to this payroll application. But when we look closer, we can see that, oh, well, the Small Council group has all of these members, and then looking, we don't see any active sessions for any of these members. So, okay, we can try to pivot around, move somewhere else, look for information, but that takes time. And the longer we have and the more things we touch, the higher chance that us as red teamers are going to be caught by the blue teamers before we can achieve that objective. So again, this is a problem of scale. If we are looking through 3,000 machines and trying to find where these profiles are at or where specific pieces of artifacts and intelligence may exist, it's going to be a very long time. You can try to loot everything from every computer, but that feels pretty irresponsible to be able to get, imagine that each one of these machines has, 10 or something users on them, and each one has all of their own personal keys, credentials, cloud information. So gathering all of those across all the machines is going to be a huge, huge amount of confidentiality and integrity that you're going to have to maintain as a red teamer versus triaging and finding just the important ones that we want to loot and why. So when we run ProfileHound, which is another, the collector that I built, what it's doing is it's actually spidering through each of these Windows machines, and it is looking for which user profiles exists on that C users folder. This does require either local administrator or domain administrator. So this is very specifically a post-compromise and post-escalation tool. This is used to create those actions on objectives where we have access to so much data, we need to figure out which data to prioritize at this point. So spidering through the user folder, we are actually associating the SIDs of the users that we're going through, and then also the SIDs of the machine, and then putting that JSON together with the Open Graph format, dropping it straight into BloodHound, and now we can see this new path that existed, that did not exist before, where it's this has user profile. So now we can see that this user, Peter Baelish, has that user profile which exists on the machine Castle Black. Again, remember, the only way to see this in vanilla BloodHound is if that user has an active session and is actively logged into that machine. But since they're not, the only way we can see that they have some possible credential material is through this kind of collection. Now, we can also look through based on group membership too. So again, our intel said, hey, small council group is supposed to have access to the payroll SaaS, and that's the one that is our specific objective. So if we can focus on, hey, who is from the small council that has a user profile on a machine, then we can graph out which ones we want to focus on. And we can say, like, for whatever reason, we already checked the King's Landing machine here, didn't have the user profile or nothing useful. So now we can see that, hey, Peter Baelish has that user profile on Castle Black. So let's take a look. This is what the collector itself looks like as we're gathering data. It is Python based, and it'll go through and actually authenticate and give that information about trying to figure out which SIDs exist in those folders and what those SIDs map up to correlate them with the existing BloodHound data to implement into there. And this has been great. It's been fantastic, used it a lot, but we got to go further, right? So lots of people can have lots of profiles on lots of machines. So we can have one user that has a profile on, 40 or 50 machines just due to the nature of their job for whatever. So what we're doing now is we can triage inside of the profiles and look for very specific artifacts or flavors of artifacts inside of those profiles so that we can triage further. So if we can see which juicy files exist, like a specific DPAPI blob, which the browser credentials are stored in when you hit that, like save my password when you log in with Edge or Chrome or something. Notepad++ backups, those live files that just happen to pop up when you close it and open it back up, those contain a lot of juicy information. Cloud API tokens, AI authentication tokens, all this stuff is usually stored inside of that profile itself. So if we can scan and fingerprint and classify these artifacts at scale, that allows us to really accelerate what kind of focus we're looking at this point too. So what we see here now is that, hey, we have the small council group, we see Peter Baelish, and then we also see that he's got Notepad++ backup, we see PowerShell history, some more Windows credential files, some browser information, and all of this is specifically on that machine too. So what we can do is really try triage and focus in on very specific artifact types, whether it's SSH keys, cloud configurations, all of these the specific intel that we can now visualize inside of BloodHound itself. And it's persistent, it's durable, so it doesn't require the user to be logged in. All we need is just to be able to connect to that machine, and then we can go over to that folder and pull it down and use it ourselves. So that is, really helped figure out, hey, this is some kind of latent identity that's just been sitting there that we've had no idea about. And, the user account could even be disabled too, right? But does that mean that the SaaS application that they were using was disabled as well? Especially if you don't have any visibility on what kind of SaaS they've been using. So being able to gather this has been extremely useful. When we're using it as an operator, we want to make sure that we are targeting objectives, triaging the profiles. We want to collect minimally because, again, we want to maintain the confidentiality and the integrity of the individuals and the organization as we are doing red teaming responsibly, and we want to prove impact because, again, anything can be done in theory, but when you actually prove that you did the things, that's when we can make the changes. On the defender side, it is very useful to help identify that identity residue. So the things that kind of just accumulate and stick around and show up long term, right? Reducing exposure and also detecting collection. By nature, this tool isn't exactly quiet if you decide to run it on everything. It's spidering all of the C $ shares on SMB across the entire domain. Like, that's not exactly quiet, right? But what's blown my mind is that EDRs like SentinelOne, CrowdStrike, Microsoft Defender for Enterprise, they don't flag on you doing all of that. It creates events on it, but it doesn't create an alert saying, hey, someone's doing all of this SMB enumeration across the entire domain. So detecting the collection or that level of SMB enumeration really should be a focus for the defender and the blue team side as well. And again, we're not trying to loot more. We are trying to focus on the things that get us to the objectives, and that is finding where the identity material exists and where these kind of identity credentials really exist at that perspective. So actually using it, you can install it through pipx, which is usually the easiest. And you do need that either local admin credential on the target machine or domain admin so we can collect it across a ton of machines at once. And if you don't submit targets inside of the actual tool when you call it, it'll pull down all of the machines from Active Directory automatically and then spider through them on its own. And we are really, using it to find where those users that we want to target are going to be. So I do have a quick demo. I might be able to sneak the time in, so we'll see. But again, we are trying to prove access to the payroll SaaS, right? That's our objective. We have a position where we've already achieved domain admin. We did try to log in with those domain admin creds or some kind of other identity in Active Directory for those specific users. No-go, didn't work. But we do have the intel that the small council group has access to that payroll SaaS application. So what we need to do is we need to figure out, all right, first, who's in that group, what kind of information do they have, and do they have profiles somewhere else? So let me see if I can pull these up. All right. So this is that small council group that we were talking about. And again, if we're looking, we can see that there are no sessions for this specific group. So we can see that there are 7 members, but how do we prioritize which ones exist on which locations? And then looking at the domain computers themselves, oh man, there's a lot. I don't want to start doing this. So then when we look at, all right, let's figure out who from the small council group has that user profile inside of the specific group we're looking for. We can see Peter Baelish has that. And then extending further, we're looking at the specific credential files themselves. And we are looking at, there's some PowerShell history for Peter Baelish that exists on this Castle Black machine. Looking down, we can see that, where is it? Here it is. So Peter Baelish in app data, roaming, Microsoft Windows, PowerShell, PS readline, console history. If you're familiar with that, anything you type into PowerShell does get logged, and then we can actually try to take a peek at that information now too. So what we are looking at is trying to connect through SMB client NG, and this is using the compromised domain admin that we have through a unrelated perspective. But we know that, hey, this is the machine that Peter Baelish has that profile on. Look at shares, use, see $, and then changing to users, we can see that Peter Baelish has that profile on there. And let's see, where is that specific file? App data, roaming, Microsoft Windows. Oh, great. So change to get app data, maybe. All right. So, apologies. Anyways, when we pull up that PowerShell, what it does is it allows us to actually see that the user has specific files inside of there, and that they leaked information about the, there we go. No, it doesn't exist. Great. All right. Awesome. So they do leak information in that PowerShell itself about using credentials inside of there. Apologies about that. Let's see. And I want to give time for some questions, but specifically some limitations and guardrails. This does require local admin. We are looking at metadata first. I do have switches in there to actually pull down some of those credential files and artifacts if you're interested, but I do want to start it by default gathering that metadata first so that we can actually visualize that without compromising the confidentiality or integrity of the users. Timestamps are really interesting signals because if a user account was created 3 years ago and it was last modified yesterday, that's probably a really good indication that they use that profile a whole lot, and it probably means there's a lot of good data on there. And then we don't exactly want to overcollect files directly unless we really want to go down that path. Again, we want to maintain our limitations as red team so we don't do too much. And then we also want to coordinate cleanup because we want to show, hey, this kind of identity is persistent. It does last a long time. How do we protect against that by identifying it in the first place? So looking forward, we've got a few different things I want to continue expanding this tool on as well. Specifically, like looking at the domain controller authentication logs for specific users logging into machines first. That way we don't have to collect every single machine in every single domain, but instead focus down to just the machines that users have been associated with in logs in the past. We can also associate primary machines in SCCM data or Azure and Entra ID. And usually the less noise and red teaming, the better. But again, everything we do needs to come together so we can all protect each other. On the red team, on the blue team, we're all on the same side, and we must work together to achieve this. So, questions? Anyone? I think we got 2 minutes.
Yep, you caught me by surprise. Right. Can we have a round of applause for Chris, please? And if there are any questions in the room, just raise your hand. Excellent. And I will get those steps up.
Awesome tool and presentation. Regarding EDR and building detections for things like ProfileHound and BloodHound, what suggestions do you have?
Wonderful question. So really that's about when we see large amounts of data gathering happening at once, that is usually some kind of indication that someone is gathering information to try and do an attack later on. Because what these tools do isn't inherently malicious. It's just, hey, does something exist in LDAP? Or let me get a copy of everything in LDAP, or what things are in this folder. That's not malicious, right? But using that information, those are weak signals that an attacker is planning something to do something later on. So associating that with other signals that are going on really helps EDR kind of focus on what things could happen later on, or what is suspicious and is worth your time as a human to investigate. So great question.
Yeah, great question. Thank you. Any other questions in the room? I just checked on the app. There are no questions online. I did have a quick one. And you kind of demoed it. So it runs independently of BloodHound. It's its own tool. You don't have to run BloodHound first or pull in any kind of data.
Great question. You do need BloodHound. It extends on top of the BloodHound data. So the things that BloodHound doesn't collect this information, but using this tool allows you to put that into the BloodHound and add to it so you can make better decisions.
Yeah, cool. Thank you. Fantastic.
Just have a quick question regarding how to bypass Defender for Identity or CrowdStrike Identity.
I'm sorry, your question was how to bypass?
Yeah, because Defender for Identity can detect that kind of the enumeration, that kind of things. How you can bypass that one?
Yep, great question. So that's why I wanted to start focusing on building where specific users have logged into machines in the past, looking through event logs on the DC, or associating in Entra ID or SCCM, where users are directly assigned machines. So we can pull that data first and then put that into this tool. We are only spidering those specific machines versus all of them in the domain.
And I'm assuming there'll be things like in that detection pipeline, there'll be something like a network detection response tool, and probably most likely see a lot of, hey, this computer or this malicious computer is all of a sudden scanning a whole bunch of other things.
Yep, exactly. And that's where those weak signals help put together that, hey, an attack might not be happening right now, but is probably going to happen because they're staging the right information they need to do it.
Yeah, excellent. Any questions in the room?
I got stickers up here if anyone wants some.
Excellent.
I got a few more.
You can always make friends with stickers, right?
All right, love it.
All right, can we have a warm round of applause for Chris Haller, please?